This is the second part of our video lecture on Introduction to Vectors. In the first part, we introduced the definition of vectors, and we differentiated it from scalar quantities. Vector quantities needs both the magnitude and the direction in order to be fully described or to be understood clearly. Some examples of vectors are forces, displacement, velocities, and acceleration. We also define what a resultant is, which is when we get the sum or when we add two or more vectors. Basic arithmetic such as addition and subtraction only works for parallel vectors because parallel vectors lie in the same axis. But if we have two vectors that are in opposite axis from each other, or in other words, they are perpendicular, one is along the x and one is along the y, the basic arithmetic, addition and subtraction will no longer work. Instead, what we are going to use are basic trigonometric functions or basic trigonometry concepts rather, which include the Pythagorean theorem, which we will use to calculate missing side length of a right triangle, and the trigonometric functions, including the sine, cosine, and tangent function of an angle. Hopefully, at the end of the video lecture, you will be able to understand why a review of these concepts in trigonometry is important when solving problems related to vectors. We are going to split this second part into two. This first portion of the second part will talk about the Pythagorean theorem, and the second will discuss the three trigonometric functions. What is the Pythagorean theorem? The Pythagorean theorem is defined as follows. If A and B are legs of a right triangle and C is the length of the hypotenuse, then A squared plus B squared is equal to C squared. Let's take this right triangle as an example. A right triangle has a right angle. You can see the right angle in this illustration right here. It is symbolized by this inverted L right here. When we say right angle, the angle is equal to 90 degrees. So if you have if two sides of your triangle forms a 90-degree angle, that means you have a right triangle. Opposite the right angle, the opposite side to the right angle right here, this side, we will call that as the hypotenuse. And the remaining sides, we will just call them as the legs of the triangle. So here we have the hypotenuse and the other two sides are the legs. We will also symbolize the hypotenuse as the letter C here and the legs as A and B. A and B here are arbitrary, the placements, meaning to say this can be my B and then this can be my A right here. But what's important is the side opposite the right angle is always the letter C or is always the hypotenuse. So looking back at the equation, we realize that you need to square the length of the hypotenuse, and that will be equal to the sum of the square of the two legs. Let's use that in calculation here. So let's say we have this right triangle. We have the two sides. The first side is measured at 5 centimeters, and the second side is measured at 12 centimeters. Since we are dealing with units of length, please expect units such as centimeters, feet, inches, and meters will also work since we are dealing with the side lengths of a triangle. Here, what is missing is C, or the hypotenuse. We can use the Pythagorean theorem to get that particular value. The theorem states that A squared plus B squared is equal to C squared. So if we assign A as 12 and B as 5, although that can interchange, meaning A can be 5 and B can be 12, it won't affect your calculation. Okay, so here my A is the 12 centimeter. I will square that. And my B is the 5 centimeter. I will also square that. If you square 12, you get 144. If you square 5, you get 25. You also would square the centimeter, so it becomes centimeter squared. That is equivalent to c squared. The next thing that you can do is, although it is not shown here, is you can also first add 144 plus 25. What you will get is 169. But here I go straight to the square rooting of both sides of the equation, which is okay. Why do we need to square root again both sides of the equation? Because remember, you are going to get the value of c, not the value of c squared. So in order to remove the square here on c, we need to put them in a square root. So again, 144 plus 25 is 169, although again not shown here. But if you get the square root of 169, that will be 13. So this length, the length of side C is 13 centimeter. One clue that you are correct in your calculation is the hypotenuse is always the longest side in the triangle. So here we get 13, which is greater than 12 and 5 centimeter. So in a way, we can somewhat check our answers. Here is another example. So here, the triangle looks split. It won't always look like this one. The first thing that you need to do is to identify the right angle. Because remember, the hypotenuse is always opposite the right angle. So we can see the inverted L here. That's the symbol for the right angle. Opposite that, the opposite side is the 12 inches here. So that means this is my hypotenuse. This is my letter C. What is missing is one of the legs, either A or B. You can decide. Here in my calculation, my question mark is my missing side is letter B. But if you choose A, that will also be okay. We will square 8 and 12 inches. Square of 8 is 64 and square of 12 is 144. So this is a bit different from the previous slide because before, on that slide, you are solving for the hypotenuse C, which is already isolated on the right side here of the equation. But here you're going to solve for the B. So what you need to do is you put 64 on the right side. So that's going to become 144 minus 64. Thus, the difference between them is 80. So again, you will have to put them on a square root. The square root of 80 is 8.9443 inches. So in order to be uniform, please report your answers with 4 decimal places for the sake of accuracy. Here is another example. So again, take a moment to identify the right angle and then the side opposite the right angle would be your hypotenuse. This time it is going to be letter C. And you are missing again one of the sides. So this is a similar problem from the previous slide, number 2. This time I considered A as the missing side. So again, doing the same thing, putting 4 squared, which is 16 on the other side. A is going to be the square root of 20, which is 4.4721 centimeters. So please get your scratch papers and your calculators and try to practice on your own. Try getting the missing side length on these 2 practice problems. You can pause the video, but I will be showing the answers in 3, 2, 1. On the next part of this second video lecture on Introduction to Vectors, I will be discussing on the trigonometric function. Thank you.